Hi kids. Previously we learned about mixtures, right? We also learned that components of a mixture retains their original properties. Today, let us try to see how to apply this knowledge to separate the components in a mixture. Let us see the objectives of this particular video. To understand the nature of the components in a mixture, to look at different types of separation techniques, to be able to decide the best separation technique for a mixture. Why and how do we separate mixtures? To start off with, let us look at the why part of it. So, if there is a mixture, it will have some useful contents and some unuseful components, correct? So, we need to get rid of the not so useful components from the mixture. So, hence, we need a separation technique. You would have seen this at your house, right? There is a mixture of dal and stone wherein the dal is the one that you require and stone being the impurity needs to be removed. So how do we do it? Which property of matter do we look at? Yes, the color and the size. The impurity here being stones definitely are very different from the dal in color and size. So we make use of that and pick out the stones from the dal. Here you can see a sieve being used as a filter to remove the bigger impurities from the flour. A similar thing is being used to remove the insoluble tea powder from the tea. These methods are ideal for these, as no other method would give the desired result. The point is, to decide the separation technique, you need to look at how the characteristics of the components in a mixture vary. Do they vary in their solubility? How about being magnetic? What about the size, the color, etc.? With this in the background, let us move on to different separation techniques. Let us now see how to separate components in a solution. The sample out here is a salt solution. The solute component here, that is salt, is soluble in the solvent, which is water. So filtration is ruled out. In these kinds of homogeneous mixtures, what else can help us separate the solute from its solvent? What about boiling? Are boiling points of both these substances the same? Won't solid have a higher boiling point than the solvent out here, which is water? Yes. Being a liquid, the boiling point of water is lower. If we raise the temperature to 100 degrees Celsius, we will be left with only salt in no time. This process is termed as evaporation. We utilize this process when we need to separate a soluble substance from its solvent. The sample out here is black ink. The components in black ink are mainly different types of pigments and they are uniformly distributed in the solvent. How do we go about separating the components in such a case? They will have similar properties, they slightly vary in their mass, but there is this one property that can be applied. These pigments have varying affinity towards different substances. Here, their affinity towards paper and solvent varies. Here you can see how components of a mixture with different colored pigments are getting separated. It is based on their affinity for the paper or solvent. If they have more affinity for the stationary phase or paper, they will move slower. If the affinity is greater for the mobile phase or water, they will move faster. The process is called as chromatography. Chroma means color and graphene means to write. Chromatography is utilized to separate components based on their affinity towards the stationary phase or the mobile phase. Here I have another sample which is copper sulfate solution along with few more impurities. How do I obtain pure copper sulfate? Can I use evaporation? In that case, even impurities are left behind along with the copper sulfate. What about filtration? In that case, any soluble impurities will be present along with the copper sulfate solution. Let us see what we can do. Let us first filter this solution to remove insoluble impurities and then boil it to make it a saturated solution. What will happen when the saturated solution cools down? Won't the excess copper sulfate be thrown out of the solution? Here you can see pure crystals of copper sulfate forming. Thus, we have separated it from the impurities. This process is termed as crystallization. This method can be used for solids having crystalline properties dissolved in liquids. In a crystalline solid, the particles of the solids are arranged in an orderly lattice. That is, they are arranged in a definite repeating pattern. Sugar and salt are crystalline, whereas glass or wax are not. Let us understand how to separate particles based on their densities now. Here, the sample is milk. We have already seen that milk is a colloid. Here, the fat particles are suspended in a liquid dispersing medium. We already have seen that filtration is of no use for colloids, as the particles can pass right through the filter paper. What do? You would have observed at home how they extract butter from buttermilk, right? Yes, by churning. What happens when a liquid is churned? The particles in the liquid separate based on their densities. The ones with lower density will come up, whereas the ones with higher density goes down, and we can now separate them easily. This process is termed as centrifugation. See what happens here. As you can see, when the milk is rotated or centrifuged, the cream settles on the top and the skim milk is at the bottom. Hence, we have separated these two from each other. Now let us see how to separate immiscible liquids. The sample out here is oil in water. How do we separate a mixture of oil and water? To decide, just look at that mixture. Do they mix well with each other? In other words, does oil dissolve in water? No, right? Such mixtures are termed as immiscible liquids. As you can see, oil floats on water as oil is less denser than water. You can separate it using a separating funnel or just by decanting it into another vessel. Once the water is collected, the stopper can be closed and the oil can be collected in a fresh container, hence achieving the separation. Now let us try to understand how do we separate miscible liquids. We already looked at immiscible liquids, right? How about miscible liquids? Yes, the liquids that blend well with each other when one dissolves in another, we call them as miscible liquids. For example, orange juice in water is miscible. Acetone in water is also miscible, and that is the sample we are going to consider now. How do we go about separating them? We can't use filtration or separating funnel. Can we use evaporation? We can, as both liquids will have different boiling points as they are different. But how do we collect them back? For this purpose, we can use something called as distillation, a process that employs condensation apparatus to collect the vapors back. The apparatus looks like this. The mixture is taken in the round bottom flask. We heat the mixture and collect the vapors when it condenses. The boiling point of acetone is 56 degree Celsius and water is 100 degree Celsius. When the temperature of the mixture reaches 56 degrees Celsius, acetone starts to evaporate. It will get condensed and get collected in this beaker. The water will remain in liquid state during this process as it has a higher boiling point. we can hereby separate miscible liquids like this. Now let us see how do we separate gases from other gases. The sample out here is air or mixture of gases. We studied about how miscible liquids can be separated using distillation, right? Now, how about a mixture of gases? Can we use something similar? Yes, and we call it as fractional distillation. We can go about it as follows. First, we need to cool and compress the air, making it liquid air. Then we need to heat it slowly in the fractional distillation chamber or column and collect the gases at different heights based on their boiling point. A fractional distillation apparatus is shown here. The basic principle of this type of distillation is that different liquids boil at different temperatures and evaporate. So when the mixture is heated, the substance with the lowest boiling point evaporates first and it is followed by the other gases. These gases are later on collected separately. Now let us see how to separate a mixture of solids. Here the sample is a mixture of potassium chloride along with ammonium chloride. How about a mixture of these two solids which have a similar size? Do we remember that ammonium chloride can sublimate, but potassium chloride cannot? So therefore, we can make use of this property to separate these two solids. In here, you can see when you heat the mixture of potassium chloride and ammonium chloride will sublimate and collect on the cooler side of thus separating from the original mixture. Now it's time to recap what we have learned till now. We'll be basically looking at mixtures, the properties of the components in those mixtures, and the process or separation technique that we will use based on these properties, and the examples that we have learned. Let's see solid and solid mixture. One of the solids is magnetic, is the property that we are looking at. So we will use a magnet, and the example is iron filings and salt mixture. Then let us look at different sized and colored components of a solid in solid mixture. We can use hand picking or sieving. Example is stones in rice. Next property, one of the solids sublimates. So we will use that property, sublimation. Example is ammonium chloride with any other salt and camphor with other substances. Let us now look at solids in liquids. So in that case, we can have two scenarios. One in which solids will dissolve and another in which solid will not dissolve in that liquid. Let us first look at solid dissolving in a liquid. If the liquid has a lower boiling point, we can use evaporation. And the example is salt and water, sugar and water, etc. Then solid is crystalline, so we can use crystallization as the separation technique. Example is copper sulfate in water. Then many solids have different affinities towards other substances. We will make use of chromatography. Example is pigment in ink, plant extracts. Let us now look at solids that do not dissolve in a liquid. The solid particles do not pass through the filter. Hence, we can use filtration as the technique. Example is sand in water. Then we have particle sizes and density varying. Then we use centrifugation. The example is colloids, milk solids from milk, water from clothes by spinning, or drying in washing machine, and cells from blood. Then we will look at solids and gases. The property is particle sizes and density variation. So we use centrifugation or filtration to clean dirty air is the example. Liquid and liquid. If it is immiscible, we use separating funnel. Example is oil and water. If it is a miscible liquid, they will definitely have different boiling points. So therefore, we will use distillation. Acetone in water, gasoline from crude oil is the example. Next up is liquid and gas. The best example is fog, wherein water particles are suspended in air. So in here, they vary in the ability to condense. As we have already studied, liquid particles are closer to each other and it is easier to condense them rather than the gas particles, wherein the gas particles are randomly moving, which has more energy and they're very far apart from each other. So we can use condensation as a technique to separate liquid from a gas. Next is gases in liquids. The best example is carbonated water, soda, or soft drinks that you drink. So in there, the gases are lighter and have lower solubility at lower pressure or higher temperature. That just means that if you need to have carbon dioxide dissolved in water, pressure needs to be applied, right? So that is the reason the minute you open the cap of a soda or a soft drink, you can see a fizz wherein the carbon dioxide is trying to come out. That is because you are lowering the pressure when you open the bottle cap. So that is one mechanism by which you can separate gas from a liquid, by lowering the pressure. Or you can also increase the temperature of the liquid, making it move apart or give it more energy, and as it moves farther away from each other, it will let the gas to come up easily. So you can lower the pressure or increase the temperature to bring about a separation between gas in a liquid. Then gases with gases. Different boiling points is the property that we'll make use of. We will use fractional distillation, and the example is petroleum products from crude oil.